All right, you guys, so we are going to do the water contaminant notes. So get your notes out and find a place to write this. So we're going to talk about various contaminants and how they are harmful. And what we're going to do first is just kind of explain how we test for these. So water testing can look at many chemicals to determine how safe your water is. So in our class, we're actually going to have some gross water that I make, and we're going to test that for all these chemicals. And then we're going to test the filters that you guys have built, filter the water through, test the water again, and see if we can get some improvement in the water quality. Okay, so we're going to make a table for some examples of simple testing. So this is very simple stuff. There are a lot of other things that can be tested for, but we're going to just show some simple examples. So in our examples, we're going to have 3 columns in this table and 6 rows. But if you want to do it one at a time, that will make sure that you have enough space, because these are going to get a lot fatter as I type into them. Okay, so first, the water test / the contaminant. So remember, contaminating things is not a positive thing, okay? All right, the risk or the importance. So some of these tests are going to be testing for something that's good to have in your water, okay? And then safe levels. So those are our 3 columns. I'm going to go ahead and bold those so that they stay more obvious, okay? Now the first water test we're going to talk about is nitrates and nitrites. So those are 2 different chemicals, nitrates and nitrites, okay? The risk of having nitrates. I'm going to put risk, and illness is a risk, general illness, okay? If you have too much of either of these in your water, but specifically shortness of breath, and death from too much. If you have way too much of these in your water and you're drinking it, you're going to be getting really sick. So safe levels. For nitrates, it's 10 milligrams per liter. So only 10 milligrams in an entire liter. For nitrites, it is only 1 milligram per liter. Above that, and it's dangerous. Okay, our next contaminant is free chlorine. Okay, free chlorine. So chloride is in our tap water, but free chlorine is a little bit different. It's an active, reactive chlorine, and it can be very dangerous. Okay, so the risk, okay, it reacts with and burns, so it gives you chemical burns, tissues in the body. Reacts with and burns tissues in the body. Okay, safe levels. We need less than 3 milligrams per liter. Less than 3 milligrams per liter. All right, next, hardness. Hardness is one way to say calcium ions, which are Ca2+, and magnesium ions, which are Mg2+. Whoops. Okay, so calcium and magnesium in our water. We need these ions to be healthy. We need these ions to be healthy. So the importance, okay, importance, all right, they help keep our bones and our hearts healthy, okay? So we get bone and heart problems if they're missing. If we don't get enough of those in our diets, you can get bone and heart problems, okay? So for hardness, we want our hardness to be measured at 75 and above. Now this is not milligrams per liter, it's a different measurement scale, but we want our hardness to be 75 and above. All right, pH, lowercase p, capital H. Okay, we might have learned about pH in biology. That's basically Let's go back over here. It's acidity. Okay. All right. So too acidic means damage to teeth and to soft tissues like your gums, okay? The inside of your throat, those are all soft tissues, okay? Your skin is a soft tissue, but it's a little harder to damage that than your gums, okay? Too basic, okay? So the opposite of acidic is basic, and we'll learn about acids and bases in another unit. But too basic, and you're gonna have digestive problems. Okay. All right, so pH, the safe level of pH is 6 to 8.5. Okay, and then our last one is alkalinity. Alkalinity, and the importance of alkalinity is it keeps the water at a safe pH level. So if you don't have the right alkalinity, your pH can swing up and down. So alkalinity is important, and we want our alkalinity to be 20 to 200 milligrams per liter. So those are the tests that we're going to be doing when we test our water before and after filtration, and those are the tests you're going to need to know about when we do our exam. So thank you for watching, and we will see you all in class.